Hello everyone, how are you all? Hope all are you good and learn something new with day by day. Now in this video we discuss about a new solution, right? A new solution related to the charging section, right? Now today we discuss about in this lesson of fast charging related issues. If a phone come to you which has a fast charging does not enable, right? What type of scenario, what type of issues a problem create, right? And what type of the faults, what type of the errors, and how to diagnose in a detail, right? We discuss in this video. Now before going to the topic, right, before going to the circuit, I will explain you about the fast charging. Now in charging section I'm already explained in a multiple times in a multiple circuits how the fast charging work, right? If a phone had a fast charging, right, support circuit must be a two charging IC, right? Now first charging IC is a main charging IC, or we call a primary charging IC, which handles the main circuit or also generate the VPH, right? The other one is a supporting charging IC like SMB or PQ. I'm already told you in my videos, right, in a charging section in this circuit, right? If you watch it and make notes, you already know. Now these two type of the IC, SMB and BQ IC, has play a support role, or you can say work as a fast charging IC, right? Now if a phone come to you related to the fast charging errors, right, what type of the errors, what type of the situation, I'm also explain to you. Now before, what is a fast charging? I will explain you how a phone convert in a fast charging. Let's say a simple phone, right, in a 4G phone, a simple phone, right? When you connect a charger, right, it start with the 0.600 milliamp. After that 1 ampere, 1.2, 1.8, 2.0, right? This kind of the scenario, right? Now when you connect a fast charging phone, right, a fast charger connected to the fast charging phone which has a fast charging circuit support, then it start with the similar, right, a 0.6 or 7. After 1 ampere, 1.2, 1.8, 2.0, it suddenly jumps, right, from 2.8, 3.0, 3 plus 3.4 ampere. Also the voltage in a fast charging support phone, right, from 5 volt to shifted to 9 volt or 12 volt. You all have must seen that. For example, like a USB ampere meter, all the technician have this kind of the meter. In this meter there are multiple charging ports. Now the one port support the fast charging, right? Now the other port's name called USB 2.0. the fast charging port called USB 3.0, right? Now when you connect a phone on a USB 2 ampere 2.0, right, a normal phone start with a 0.6, a similar pattern 1.2, 1.8, 2.0, right? This kind of thing scenario. But when you connect a USB 3.0, a data cable, also a phone supported a fast charging which has a two charging IC, let's say, right? Then after this is same circuit, it will goes up to the 3.4 ampere, also 5 volt to 9 volt. You can easily see on a USB ampere charger, this one, right? But if you connect a fast charging phone on a USB, let's say fast charger charging support phone, right, fast charging phone to USB 2.0 ampere, what was the scenario? A similar scenario like this: 0.6, 1.2, 1.8, 2.0, nothing changed. And if you connect here on a USB 3.0, a normal phone, it will charge will be the same 0.6 to 1.8 to 2.0, or you can say 2.2 maximum. Now the charging concept, especially for a fast charging concept, there is a special circuit in your phone, also in a charger, right? When you connect a fast charging supported phone, right, also a fast charging charger with a charger, they communicate with each other. We call a PD, a power delivery concept. Power delivery concept. So after communication, when the charging starts in a normal way, it switch up to do 5 volt to 9 volt and 12 volt. Also the ampere increase 3 plus ampere, 3 ampere to 5 ampere, according to the circuit to circuit. Right now you have clear, right, how the circuit work in a fast charging, because they communicate with each other, right? If this communication drops, right, the fast charging doesn't work. Now I will explain you, I will show you the fault, or you can say the topic, the main topic, right? Now in front of you, this is a motherboard, the motherboard of a Redmi K40, right? This is a 5G phone. You can see here multiple PMU, right, the multiple power. Also a PMU name PMB, right, 8150B, this one. This is as a working as a PM, also working as a charging IC, right? So secondly, there is another called charger BQ25968, this one, this IC, the BQ series. So in this one there is a 2 charging IC. Now talking about the fault, let's assume a phone come to you, which has a fast charging related issue. I will tell you, I will explain to you. Let's say customer give it to your phone, right, and customer told you, when the customer connect charging in a off condition, right, when the customer connect charging in a off condition, charging okay, right? Listen properly. When the customer connect a charger, right, in a off condition phone, it's okay. This phone is a fast charging supported phone. But when it's tried to turn on the phone, right, after turning on the phone completely, when the charger connected, right, it's connected. After few seconds, let's say 2 or 3 seconds, it's disconnect automatically. Till after a second, it's connect automatically. Customer did not touch any wire or charger. Similar or disconnect. So this pattern goes on. Connect, disconnect, connect, disconnect, connect, disconnect. When it's connect a charger after switching off, it will the phone completely charge. But when it's turned on the phone, right, after connect a charger, connect, disconnect, this kind of the issue create, right? Some people doubt maybe a fault on a CC, a charging connector, right, a charging jack, charging connector, maybe a subboard, maybe a charging flex. But let me tell you, in a off condition, the charger completely working, right? That means these all are okay. Fault related in a motherboard, right? A motherboard faulty. I think you have understood the fault. Now how to diagnose this type of the fault if a phone come to you, right? Clear this. Now when a phone come to you, like this type of the phone, this type of the issue, right, or you can say this type of the problem come to you, before start the repair, first of all always think like an engineer, right? A logic, right? Start with the logic. Now, first thing, your first job when a phone come to you, because you have a USB ampere charger. Customer does not have a USB ampere charger, so you test by own. It means, right? So your first job, connect wire, a charging wire with the USB ampere meter. First 3.0 ampere meter, and let me tell you, it will show you a same pattern. When you connect in a on condition, it's connected and 0.6, 1.8, and after 0 again 0.6 without removing the charger, 1.2, 1.8, 0.0, and this pattern goes on. When you connect after the switching off, right, it will goes to the 0.6, 1.2, 1.8, right, after 0.0 and 1.8, and the charging start. That means your phone charged. Now when you connect this phone on a number 2 USB 2.0 on a off condition, it's proper working, right? A similar 0.6, 1.2, 1.8 ampere. Now after turning on, right, when you connect it after turning on, it will properly charge like 0.6, 1.2, 1.8, 2.0. There is no error, no connect disconnect error when you connect with the USB 2 ampere charger. Now why this problem? If you think, because the customer use a fast charger, company provide charger, the fast charger, and the fast charger switch after 2.0 ampere to 3.0 ampere, right? Also 5 volt to 9 volt to 12 volt. When the phone switch to 5 volt to 9 volt or 12 volt, there must be a error on a secondary IC, or you can say the fast charging IC. Any line short circuit, the fast charging IC does not work, or any communication, right? Due to this, when the charger switch to normal mode to the fast charging mode after 2.0, it will reboot. That's why the phone turn on. When the phone turn on, it will show you a connect, a disconnect, a connect and disconnect. But when the phone turn off, right, it will stay on a low ampere charger, I mean to say in a normal mode, not turning on a fast charging, because the communication also off. Similar on a USB 2 ampere 2.0, right, this is a USB 3.0 of fast charging support, right? You all have must seen that when you connect a fast charger with the USB 3.0, it will shift it to the 5 volt to 9 volt, also sometimes 12 volt, also the ampere increase, right, for fast charging. But if you connect a 2.0, it's working on a 5 volt and max 2.2 ampere, right? Now this is the fault, right? Now on number 1, through this you get a clue, or you can say get a hint. A USB, it means the fast charging does not activate, enable. Whenever the phone switch to the fast charging mode, right, 5 volt to 9 volt, shifted to the 5 volt to 9 volt, it's drop to 0. Also whenever the current ampere from 0, I mean to say 2.0 to above 2.8, 3.0, it's back to 0 and again start when the phone turn on. Because when you connect a fast charger, right, and the charging start with the 0.6 or 2.0, right? When it switches to the try to communicate with the charger, a fast charging enable, but maybe the IC does not support due to any reason. Maybe the IC faulty, maybe the IC any line, right? Due to any line, maybe any line does not work, or circuit open, or any line short, IC faulty, communication break, any reason. So fast charging circuit does not work, so it will came back to disconnected. CPU think there is an error, so it's disconnected, but again it start with the 0 because charger connected, right? Now according to the programming, sometime it changes this kind of the scenario. Just you have to think like an engineer, what type of the problem and what type of the causes, right? Now we go to the circuit, and I will show you the steps. So this is the motherboard, right? Now there is a 2 charging IC, right? Now look at here, there is another main charging IC and secondary. Now this is the B2B connector where the subboard connects. So number one thing, we does not check the main primary IC, because in a USB 2.0 ampere charger, it's charged properly, also in a off condition. Problem somewhere in a secondary charging IC, right? So so this is a layout, right? Copy this layout. Now this is schematics, paste in schematics. Next, zoom. So this is a charging connector, right? Now copy VUSB. Next, there is a TP here, test point here, somewhere here. Now this here. Now this line, a V bus connected with this IC. There is a MOSFET. You will see drain, source, gate, right? Now let's say 5 volt enter here, because charging start with the 5 volt, right? Now in this line, there is a line connected from the V bus, a 0 ohm resistance, and this line called VAC, voltage adapter current. So when the charger connected, this line is like a detection line, right? A detection line. We follow this line. Now this line came to this IC. This is a BQ25968, right? Now from here there is a OVP gate. When you click this, now this IC enable the gates. That means I'm already explained this circuit in a charging circuit. Now I'm explaining you again, not in a proper detail, just related to this volt. So when you connect a charger, 5 volt here, 5 volt with it through this resistance goes to the BQ IC. When BQ sends a charger connected, right, adapter connected, this send a enable signal, right, to the gate to enable this MOSFET, right? After enable, right, this 5 volt enter here, right? Clear? So when you click here on the output side, now this line goes to the secondary charging IC. Also this one is a main charging IC, PM8150P, right? And this one is just BQ25968. So the main charging IC work properly, right? Here V bus in, right, the boot cap switching, that's why it's taking 1.8 ampere 2.0, and the VPH is also generated because the phone is turning on properly. It's working in a charger, also in a battery mode properly. So this IC is a proper okay. We do not need to test, or you can say check this IC, right? The fault must be on a secondary IC. So we connect again. Now this is a secondary IC. Now I will explain you which lines are responsible due to this fault, right? Now first of all, if the output V bus does not connect, right? If you get a 5 volt enter here, let's say, but it does not connect, right, on these pins internal the IC, right? On this scenario, the same fault, because the power IC need to run a main voltage. This is a main voltage to run the PMU, sorry, this charging IC, right, a V pass. If the V pass does not connect, does not enter in this IC, right, this IC does not activate, right? So this type of the fault, right, whenever the phone shifted to the fast charging mode, because there is a IC does not work, it's a shutdown, right? Right now it's not working, so the charging stopped by the CPU and it start again when the charger, or you can say when the protocol finding the fast charging it's not available, then it's again stopped. So this process on by on. So first line, the VPAS, right? Secondly, there is a PMID. Similar process, if you get a 5 volt here, that means this V was connected. Same protocol. Now this capacitor here is a C drive capacitor, a charging drive capacitor, right? Also there are multiple caps, 1 2 3 4 5 6 7. Let me explain you again. These all caps, 1 2 3 4 5 6 7 8 9 10, right? These 10 caps, also a 1 C drive cap. These all caps are charging pump cap. Charging caps are pump cap for charging pumping. These IC working on a capacitive base. Capacitive base charging, a charging pump. Basically in the main charging IC, if you see, there is a coil switching with the MOSFET and the boot cap, right, after the high ampere generate. But this IC generate the high, for generating the high ampere, it switches, right, with the capacitors to generate a high ampere. So we call a pump charging, capacitor based pump charging, right? So in this case, any capacitors series does not work, right? So it does not generate the high ampere. So in this case, the output does not retain, or you can say sustain, right? If the output problem, then the reason also this IC does not work, because when this IC does not generate the high ampere, right, it does not help in the fast charging, so it automatically deactivate. So these all caps you must check. Like on this cap you have to, let's say, like one side you will get a 4 volt, other side you have 5 volt, similar 4 volt 5 volt, and the different diode value, charging fly high, charging fly low, CFH, charging fly high, charging fly low, right? Same here, charging fly high, charging fly low, right? And this line is for the output connected to the battery connector, a VBAT line. If this line is open, break, the same scenario. Now these two are sense lines, right? Through sensing line, a different type of the problem generate, but not like this, right? Now there is another lines called interrupt. Now let me explain you. Interrupt, INT. Interrupt is like a wake up signal, right? For CPU, multiple time told you, when you connect a charger, so this IC send a signal to CPU, charger connected for switching the fast charging mode. If this line is open from the CPU, right, or disconnected, no communication, right, then this problem create. Now how to tackle this line? For this we have to copy this line, and next. Now in this line there is a no component. This line directly connected to the CPU from in a IC C7 ball in a CPU GPIO 68 T4. Okay, so how do you check this line had a faulty or not? Because in this there is a no component here. So like I'll explain you. Like this is a CPU and this is a charging IC, a secondary charging IC. This IC send a wake up signal called interrupt. Right now this line connected here, this line connected here. Right now this IC has a diode value up, right? The charging IC diode value. There is a CPU diode value. Now for the testing, this line connected or not or any time somewhere. Now by chance this line is break, this kind of the issue. For testing you have to must remove this charging IC because there is no other way. After removing the charging IC, one point on a ground, right, on the black probe, right, it means on a reverse bias, on a diode mode, you get a diode value here. If you get a diode value, let's say from 500 to 700, right, now this diode value belongs to the CPU, right, let's say 300 to 700, accordingly the multimeter, right, that means your CPU is connected. If this line is a OL or 1000 plus rating, that means this line disconnected. On that scenario you have to connect a jumper under to under IC. Right now after this there is a SDA and SCL. These are protocol lines, protocol lines, a communication line. Through this CPU communicate with this IC, read data and the write data, right? Also explain you in a charging section. That's why I'm always ask you, whenever you watch the video, watch it again and again, also the make notes, so next time your mind will be automatically prepared, right? Also the whatever the circuit, right, I will teach you, it's automatically stored in your mind, right? Now how do you test? Now copy this line. Now this line has a pull-up resistance, right, VRAG S4 1.8, right? Also this line connected to the CPU, the both line I2C SDA and I2C SCL, serial data, serial clock. Now I will explain to you through this circuit, so it will be better for you. Let's say this is our charging IC, right? Now a line, right, connect to the CPU, let's say here, right? This is called SCL, always a clock first, right, after SDA, right, for both sides, read and data. Through the SDA it's read and data, for the clock it's communicate, I mean to say for the synchronization, right? Now these two lines, now in these two lines there are two resistance, let's say here, one here, one with this one, right? Now VRAG 1.8 voltage. Now this circuit, now this line connect here, this line connect here, this line connect here, connect here. Now how do you check? First you check with the DSO on these resistance, a clock signal, right, a data signals. But if you do not have a DSO, mostly technician does not have a DSO, so how do you check? How do you confirm? First of all, check the both resistance location, right, after a 1.8 voltage on both resistance. If you get a 1.8 voltage, check the both resistance value, 2.2k according to the schematics, right? Let's say in some circuit 1.4k to 2.2k max, right? So let's say the both resistance is also okay. Now how do you, the next step, for the next step you just remove this IC, this charging IC. Similar like an interrupt, you have to test this lines, both lines. Normally in a okay condition you will get a 400 to 700 diode value, but let's say you will get 1000 or 2000 plus value, or OL, or any line you will get, let's say 650, other line you will get 1800. Let's say SCL is okay and the SDA give you this value. That means the SDA has a problem. If both line had a problem, then you have to must repol first. Open the CPU, first check the communication, both line connected or not, right? If they are connected, then you have to repol the CPU and your phone turn on properly, working properly. If any line, let's say on a SDA had a 1800 value, that means the SDA line open. On that case, you also remove the CPU, check the communication. If the communication break, then you have to make a jumper from here to here, right? Clear? Now this is a small IC, right? But this is an important one. It's look easy. I'm already told you in a previous video, it's look easy when I told you, when I explain you, right? When a fault come to you, it's not like a similar fault come to you. For example, as a teacher, taught you, or you can say teach you, a 2 plus 2, 4, 3 plus 1, 4, right? Okay, but the next time in exam time, a question comes 1 plus 3 equal. If you learn properly, right, and you have a mind, right, then you get a 4 answer. Otherwise, you think the teacher does not cover this. Teacher never teach this. I hope you get my point. That's why I'm always told you for the practice, making notes. Whenever a phone come to you, right, making notes, diagram, and practice it. Like this one is a PM8210P. Open this IC on a Borneo, not a similar model. Open another model, 2 or 3 model. Now make diagram, starting with the V bus. When you do it from 20 to 30 diagrams in a charging related, you will see all the data automatically store in your mind. Automatically all doubts will be clear, right? So this is a process basically. So in the next video we will meet you with a new solution, right? Hope all are you good.